A capacitor is an element used to temporarily store the electric charge. Capacitors are used for a variety of applications. Even a small electronic device like a mobile phone uses nearly 100 capacitors. Among the uses of capacitors are temporary storage of electrical energy, AC and DC separation and selection, phase shift between voltage and current, and signal differentiation and integration. While external appearance and structure may vary from capacitor to capacitor, the basic structure can be represented by a pair of electrodes. When voltage is applied between these electrodes, the electric charge accumulates on the surface of the electrodes. The larger the surface area of the electrodes, the larger the amount of electric charge that can be stored. The narrower the distance between the electrodes, the larger the amount of electric charge that can be stored. The amount of storable electric charge can be increased by inserting an insulator, known as a dielectric, between the electrodes. The characteristics of capacitors differ according to the type of dielectric used, making it possible to employ capacitors for a variety of applications. Some capacitors have no polarity. Others do have polarity. The capacitors shown here are in common use. They represent a small proportion of all capacitors. Regardless of polarity, capacitors are indicated like this in electrical circuit diagrams. An exception is the electrolytic capacitor, which is indicated like this to differentiate it from the other capacitors. When voltage E is applied between the terminals of a capacitor, a proportional electric charge Q is stored in the capacitor. The proportion coefficient C is known as electrostatic capacitance. The following formula is obtained. Q, electric charge, equals C, electrostatic capacitance, times E, voltage. Aluminium electrolytic capacitors offer high capacitance at a low price, leading to their frequent use for applications wherein the voltage of the electrical circuit board must be kept constant. Compared to other capacitors, however, they have a relatively short useful life, about 7 to 8 years on average. This does not mean that they cannot be used after 7 or 8 years. It means that electronic devices that use aluminium electrolytic capacitors may begin to generate heat or emit noise as they age. Using the aluminium electrolytic capacitor in a cool environment lengthens its useful life. Research indicates that useful life can be doubled by reducing the ambient temperature by 10 degrees Celsius and trebled by a reduction of 20 degrees. On any electronic circuit board, numerous aluminium electrolytic capacitors are used. The lifespan of these electronic circuit boards is generally determined by the lifespan of the aluminium electrolytic capacitors. A spare electronic circuit board is provided on board ships in case the board in use breaks. This spare electronic circuit board must be placed in a cool place to ensure that it can be used over an extended period of time. However, the electronic circuit board may become rusty if this cool place is humid. To prevent rusting, an electronic circuit board can be stored in a plastic bag, along with a dehumidifying agent.